Hi there grade 8s and welcome back to WorksheetCloud Maths. I hope you're all well today and those of you that are joining us for the first time, I hope you're going to have an amazing time in this lesson and you're going to want to come back again. Those of you that have been with us for a while, again I hope you're also going to have an amazing time and you're going to learn something new. Okay, today we are going to be looking at surface area and volume, and as you can see it is the second lesson. And you can go back and find the first lesson and watch the first lesson. But today we are going to go on and we are going to look at the surface area of a right triangular prism. Okay, so the surface area of a 3D shape is the total area of the outside of that object. So every face needs to be added, the surface area needs to be worked out for each face of the object and then added together. Okay, so looking at the surface area of a right triangular prism, a right triangular prism is a prism whose bases are triangles and the three other sides are rectangles. So if we have a look here, there we can see a triangular prism, There's the base that's a triangle, another base that's a triangle, and then the other faces, this one, that one on the side, and that one on the other side, are rectangles. So as you can see, because the bases have three sides, there will only be three lateral faces, which are all going to be rectangles. Okay, so an example of a triangular prism in real life would be a camping tent or a Toblerone box. Quite exciting, you can do maths with a chocolate. Okay, so there's a picture of a tent. As you can see, that's a triangular prism. There's the triangular base and the one on the other side, and there's a rectangle. The bottom is a rectangle and the other side is a rectangle. And again, there is a Toblerone, same thing. There you have a base, a triangular base, the same thing on the other side, and then you will have three rectangles that make up the lateral faces. Okay, so if we have a look at the bases of the triangular prism, they can be any triangle. They can be an equilateral triangle, it can be an isosceles triangle, and it can be a scalene triangle. Now, equilateral triangle is very easy to work with because we know that all the sides are the same size. Isosceles, we know that two of the sides are the same size and the other one is a different length. And a scalene triangle, none of the sides are the same. But these can all be bases of a triangular prism. Okay, so sometimes when we are working with these triangles, we might need to use the theorem of Pythagoras in some of the calculations to work out an unknown side. And as long as we have the perpendicular height, we are able to do that. Right, so looking at the surface area of a triangular prism, to work out that surface area, you need to add the areas of all the faces together. So you need to find out the area of the two triangular bases, and those would be congruent. So you need to find out the one and then double it, and then you need to find out the surface area of each rectangle and then add the two lots together. So the area of two triangles and the area of the three rectangles added together will give you the surface area of the triangular prism. So there's a triangular prism. As you can see, we are given the height here. If we are not given one of these sides, we can always work out the side using the theorem of Pythagoras. But let's look at the net. Okay, there's the net of that triangular prism. And as you can see, there are the two bases and there are our three rectangles. All right, and so that would be our perpendicular height as it is shown over there. Right, now there is side A, and that is side C, and there in the middle here is B. That A and that A are actually the same length because it would be that side. It's where your triangular base meets your one rectangular face. Okay, and then C here would obviously then be C there. But we have B in the middle, which actually forms the base of our triangle. Okay, so as I said, C and C is actually one side. If this was our side A, our edge A, that would be our edge C, and the base would be B. Okay, everybody happy with that? All right, so what we would have to do is then also look at the height, and that's with a capital H because the small h is the perpendicular height. So that would also be very important to work out what our area of each rectangle is, because in a rectangle that height is actually the length and that side is the breadth, and the breadth. Now guys, if it is an equilateral triangular base, then all of these would measure the same. Can you see that? Because that would actually be that side and that would be that side. All right, so all of them would be the same. If it was an isosceles triangle, then that one and that one would be the same and this one would be different. But if you have a look closely also, this whole thing is a rectangle. So how do you get this side of the rectangle? Well, it's A plus B plus C, right? Everybody agree with that? So there we go. That's the side of our big rectangle of the net of a triangular prism, and that would be the other side. So it would be H, the height, times by the total length there, and then obviously you find this area of this triangle and the area of that triangle, and then add it all together. So as I said, we would have two of the triangle bases as their area. We have to find out that. Then we would go A times H plus B times H plus C times H. So it's finding each one individually. But let's try and make this simpler. 2 times a half, so remember it's not 2 times the whole thing because there's a plus here. So it would be 2 times a half. Well, that cancels itself out, doesn't it? Because 2 times a half is 1. All right, so we can leave that out. So that will give us B times H. So it's the base times the height. Because we've got two of them, we don't have to halve it. Okay, then we take out an H from each of these brackets because that is our algebraic knowledge coming into effect. Take out the H, and what do you have left? A plus B plus C. And as I said to you, that is like saying this whole side of the rectangle times by that side of the rectangle, and you're going to get the whole surface area. So actually what it does is it simplifies our working out, because if we've got a simple formula like that, it's so easy to plug into that formula. Okay, so let's see if we can work out the surface area of a triangular prism. You calculate the area of this triangular prism with the base being an equilateral triangle. That's important to note. Okay, so there we have our triangular prism with our height put in there, and we don't know this side, but let's have a look what else we do know. Okay, we do know the height, which is 50. That's A, that's B, and remember it's an equilateral triangle, so whatever this is, those two are going to be the same. And we are told that is 30 millimeters. So we've got one of the sides of our equilateral triangle, which means all the sides are the same. And we have got our height, which is 50 millimeters. Okay, so let's see what we need to do. Obviously, that is going to be half of that. And remember, to work out the area of our triangle, we've got to say half base times height. Right, so we don't know what the height is. So we need to use the theorem of Pythagoras here. So let's see. Our height is not our hypotenuse. Okay, A is the hypotenuse in this case. So A squared is equal to the height squared plus half of C. Okay, half of the base. Right. So what is half of the base? It would be 15 millimeters. So we've got 30 millimeters squared is equal to B squared plus 15 centimeters. So why do we know this? Because this is an equilateral triangle. That's why it's very important to read all the information that you're given. Because it's an equilateral triangle, we know that A is 30 millimeters. Okay, we don't know what that is, so that should be an H, not a B. So we are needing, let me just correct that for us quickly. There we go, I've just corrected that for us. So we've got again our A, which is 30 millimeters. Where did we get that from? From the knowledge that that is an equilateral triangle. Okay, we're working out H, so that's the unknown. Plus 15, where did we get 15 from? Well, the base is 30, so we have to have half of that. Okay, so 30 millimeters squared will give us 900 millimeters squared is equal to H squared, which we still don't know, plus 15 millimeters squared gives us 225 millimeters squared. Okay, again, use our knowledge of algebra So we're going to take the 225 across the equal sign. We're going to go 900 minus 225 gives me h squared. That gives me 675 millimeters squared is h squared. We then have to square root 675 millimeters squared to give us h, and it gives me 25,98 as our height. We now have enough information to work out the area of our triangular bases, and we also have enough information to work out our rectangular faces. Okay, and remember we looked at what the formula was just now or earlier, so now we can plug in. Okay, we can then say what the base is. The base is 30, the height is 25,98, then the height of the whole prism is 50 plus 30 plus 30 plus 30, because those are the sides of our equilateral triangle. Okay, and there we have all our measurements. Remember, we don't have to say half base because we're just going to multiply it by 2 anyway, because we have 2 triangular bases. So 30 millimeters times 25,98 is going to give us 779,4 millimeters squared. Then we've got to say 50 times 30 plus 30 plus 30, which is 90. So 50 times 90 gives us 4,500 millimeters squared. Add those two together, we're going to get 5,279,4 millimeters squared for the surface area of the whole triangular prism. Okay, everybody happy? Remember, if there's anything you need to ask, send an email to grade8@worksheetcloud.com and somebody will get back to you with an answer. Otherwise, go back to the beginning of the video and just watch it slowly and pull it apart as you're going and make some notes. Right, let's go on. Let's try another one. Here we have, this definitely looks like a tent. Here we have another triangular prism, and we are given the measurement of the height and the measurement of the base. We are also told that this is an isosceles triangle, as you can tell from the markings. We're given the height of the whole prism, but we are not given this side, which is the side of the triangle, which we need to find out. Well, we don't need it to find out this area, but we certainly do need it to find out the area of our rectangles. Okay, so that we're going to name A, so that we can actually use the theorem of Pythagoras to work out what A is. Okay, so here we are going to use the measurements from the triangles to help us work out the surface area or the area of each rectangle. Okay, so we've got A squared, which is hypotenuse, is equal to B squared plus C squared. Okay, so we're going to have B squared as being our height and C squared as being our base. All right, so it's 10 centimeters all squared plus 4 centimeters all squared. See, again, I have written this in brackets. Why? Because the whole thing needs to be squared. If I didn't have brackets, it would mean that it was squared already. So 10 times 10 will give me 100. 4 times 4 will give me 16 centimeters squared. We add those together, we get 116 centimeters squared. Remember, that gives me A squared. I don't want A squared, I want A on its own, which means I have to square root the 116, and I end up with 10,77 centimeters. Okay, now here this is actually a longer number, but I have rounded it off to the second decimal place, and I urge you to do the same when you're working out. When you have a very long answer, just round it off to the second decimal place, unless the instruction tells you to round it off to the whole number or the first decimal place. It's just easier to work with when you are rounding off. Okay, but anyway, we have now got the measurement of that side, which means we can now work out the surface area here. Okay, so let's have a look. There is our formula. A is now 10,77. That side is the same, but this side would be different. Okay, so we've got 8 centimeters times 10 centimeters, because that will give us our area of our triangular base. And then our height is 20 centimeters, and we multiply that by that side plus that side plus that side. So it's 10 plus 10 plus 8. Just one moment. Sorry, I just figured out the mistake that I had made. It's not 10 centimeters, it's 10,77. That was the whole point in working out A. So 10,77 plus 10,77 plus 8 from that base, and we are going to add those all together. We then end up with 80 centimeters squared from the 8 times 10, that would be our triangular base, plus 20 centimeters times, adding all those together gives me 29,54 centimeters. Multiply that, we're going to end up with 590,8 centimeters squared. Add on our 80 from our two triangular bases, and we end up with an answer of 670,8 centimeters squared. Right, let's see now if you can try one. So there is our triangular prism. I want you to pause the video. I want you to figure out which side, or if any, you are lacking a measurement for. Try and work that out, and then try and work out the surface area for the whole triangular prism. So pause the video now. When you come back, we will go over it together. Right, let's see how you did. Okay, so there's our triangular prism. We are missing this side because here we are told that that side is the same as that side, which means it is an isosceles triangular base. That will be 6 and that will be 6. We've got the 9, but again, we don't have the hypotenuse. All right, so let's name it A, and let's use our theorem to work out what the A is, which is actually the breadth of the rectangle. Okay, so A squared is equal to B squared plus C squared. So B squared and C squared are actually the same measurements because it is an isosceles triangle. So it will be 6 meters all squared plus 6 meters all squared. That will give me 36 meters plus 36 meters. It's 72 meters squared. Okay, that's A squared. We want A on its own. So we're going to square root the 72, and it's going to give me 8,49 meters. So that's that side. All right, so now let's plug that into our formula, and we're going to get B times H. So the base times the height, which are both 6. And we're going to get the height of the whole prism, which is 9, times by, sorry, I've made a mistake here again. No, I haven't. I'm so clever. Sorry about that. We're going to do 6 plus 6 plus 8,49 from there because we've worked out that. Okay, so let's add those together. We're going to get 6 plus 6 plus 8,49 is going to give me 20,49 meters. 20,49 meters times my 9 meters already, that's the height, going to give me 184,41 meters. Add that to the two triangular bases, which is 36 meters squared. We end up with 220,41 meters squared. Did you get that? I'm sure you did, because I'm sure you know exactly what to do. Just remember, if you have any queries, don't forget or don't hesitate to send an email to grade8@worksheetcloud.com. Right, let's continue. Okay, how about this one? Work out the area for this shape. Oh my goodness, this is quite a detailed shape. So what do you think we have to do? Okay, the first thing is that we have to break up the shape. We've got a triangular prism here and a rectangular prism here. Okay, so the surface area of the triangular prism, but we have to do it without the base rectangle, which is this here, because we want the surface area, which remember, it is all the surfaces that are on the outside of the shape. That surface is not on the outside of the shape. It is actually a shared inner surface, if that makes sense. So we've got to work out the surface here without the base rectangle, and we've got to work out the surface here without the top rectangle. So let's see how we do that. Okay, so first of all, I've got to go 2 times half. Let me just correct this because this is a very long way of doing things. Actually, guys, we're going to use this formula just because we don't need that rectangle. So as you can see here, it's 2L times B. Okay, so we're going to go 2 half base times the perpendicular height, which we can just go base times height. Okay, and then this rectangle and that rectangle. And then we've got to do 3 of these rectangles. Remember, it's not 4. And then we've got to go the 2 bases, which are also rectangles. So this is a rectangular prism. This is a triangular prism, but we can't use that there. Okay, so let's go through this because there is a side that is missing. We've got a height here, but we don't actually have that side for the rectangle in the triangular prism. So let's plug in what we've got. We've got 2 times half times 3 times 4. Okay, the 3 being the base there. Okay, I've jumped the gun a bit here. 3 being the base there and the 4 being the height. Okay, but I've got to go plus 2 this side times 12,5, and the other side would also be the same, but I don't know what this side's length is. Okay, then I've got to go 3, that's 1, 2, 3, for our rectangular prism, 4 by 12,5, because that's 4 by 12,5, and it's 1, 2, 3. And then I've got to go 4 times 3. Just one moment, there is a mistake here. Sorry guys, I'm not so clever after all. It's 2 sides at 4 centimeters times 12,5, which is that one and the one on the other side. And then the one at the bottom is 3 times 12,5. Okay, and then the bases are 4 times 3, and there's 2 of them. All right, so just to go through it again, we've got our 2 triangular bases for our triangular prism, which is going to be 2 times half times 3 times 4, because that's our height. We don't know this one yet. We will work that one out just now. But then we've got 2 rectangles that we need to find the area for. And then with our rectangular prism, we've got 2 at 4 times 12,5, 2 at 4 times 3, and then 1 at 3 times 12,5, because it's the base. If we were finding that surface area as well, we would then have 2, but we don't need to because that's inside the shape, and we only need to find the surface area of the whole shape. Right, so how are we going to go about finding out what we are missing here? The question mark, and that is that line. So we now need to actually use our theorem of Pythagoras, and here we're going to go, the question mark squared is going to is equal to 4 centimeters, which is the height, squared, which is our perpendicular height, times 3 centimeters, which is our base, and that should actually be half of 3 centimeters because it's half the base. Okay, because we are going to be working with that triangle there, or the half of the triangle. That's our perpendicular base. So I just need to correct something once again. Here we go, I've corrected it for us. It's actually 1,5, because remember, we are working with the height here and half of this base. Okay, so it's 1,5 centimeters squared plus 4 centimeters squared is going to give us this side here. So 4 centimeters squared is going to give us 16 centimeters squared. 1,5 squared is going to give us 225 centimeters squared. Add those together, we get 18,25 centimeters squared. We've got to square root that to find out our question mark, and that's going to give me 4,27 centimeters. We can now put that in for where the question mark is. We can substitute it in for the question mark. We're going to get, this is the area of our triangular base. This is going to work out the area of our rectangular bases, and we need 2 of those. And then we've already worked out 4 times 12,5 is going to give me 50 centimeters squared. And then 4 times 3 is 12 centimeters squared. We're going to multiply that by 2 because we've got 2 of those ends, okay, of the rectangular bases. And 3 times 12,5 centimeters is 37,5 centimeters. Okay, everybody happy with that? Right, so that would be our bottom rectangle of the rectangular prism. So let's carry on working out. We're going to go 1,5 centimeters times 4, going to give me 6 centimeters squared, and we've got to multiply that by 2, because 6 centimeters squared would be our one triangular base. Okay, then we've got to work out 2 of our rectangles, because it's this one and the one on the other side, and that's going to be 4,27 times 12,5 gives me 53,375 centimeters squared. Got to double that. Right, we've already worked out our area of all the different faces in our rectangular prism. We've got to double this one to get 100 centimeters squared. Got to double the 12 to get 24 centimeters squared. And I'm just going to add that on. And don't forget the centimeters squared there, like I did. Right, let's add them all together. So 2 times 6 is 12. multiply that out, it's going to give me 106.75 centimeters squared. I need to add those together to get the surface area of the triangular prism. And here's our surface area of the rectangular prism. It's 161.5 centimeters squared after adding all those together. Right, I add these two together. 118.75 centimeters squared is the surface area of our triangular prism. Add together with the surface area of our rectangular prism, remembering we did not include that. So adding it together, we get 280.25 centimeters squared is the surface area of this shape, which looks pretty much like a house. Okay, so if we were working out the surface area of the outside of a house, that is exactly how we would do it. We wouldn't even look at that calculation there. That would be our bottom surface area plus our roof, the other side of the roof, and the front and the back of the house, and the front and the back of the actual house, and this would be the front and back of the roof. Okay, so we have worked out that entire surface area of that shape. It was quite a long process, but if you do it bit by bit and you check as you're going, not like I did, but you check what you are doing, you will be absolutely fine. Right, so thank you for listening to today's lesson. I hope you come back again and watch a further lesson in grade 8 maths at WorksheetCloud.com. Thank you guys, keep well and keep warm, and I'll see you next time.